In this video, we're going to do a collaboration between this channel and our hardware channel, Custom PC Hardware, where you can go to explore the hardware used in this video. The subject of the video is a performance test between the new Minisforum BD795 computer and the Octo 2 computer I use for video editing, by doing a threaded processing task. The test will be to do some processing on a large file of 100,000 records by slicing the large file up into sections and creating a threaded function to process each section. We'll cover the actual software used later in the video. Both of these computers have AMD processors. Octo 002, which has a Ryzen 7 3800X 8-core processor running at 3.9 GHz and 64 GB of memory. Mini 001 has a Ryzen 9 7945HX with a 16-core processor running at 2.5 GHz and also has 64 GB of memory. Both of these computers support hyperthreading, so it's a race between a 16-thread and a 32-thread computer, which will complete the task faster. The Minisforum computer runs at a slower clock speed, but it is a more recent processor. The Ryzen 7 computer has a faster clock speed, but fewer processing cores. First, we're going to run this application on the Octo 2 computer. That's the Ryzen 7 16-thread computer. To allow Windows to handle the load, the application will only use half of the processing cores, so it will run in 8 threads. We can see 2 windows here. The actual processing is being reported on the left, with entries for each section and the number of records per section processed. On the right is a small graphic courtesy of the Process Lasso application. This illustrates the load on each of the processing cores of the computer. If we speed through to the end of the processing, we can see how long this actually took. And there we have the answer. The entire process took 59 seconds from start to finish. So now, if we switch to the Mini 001 computer and run exactly the same process on it, as this computer could support 32 threads running, the application will attempt to run 16 threads for the processing. Again, we have 2 windows showing, the left reporting on each section being processed, and Process Lasso displaying the percentage activity on each processing core. As before, we will speed through to the end of processing. We can now see that the data was processed in only 35 seconds. So in conclusion, for this multi-core processing task, despite it having a lower base clock speed, the new Minisforum computer has beaten the Octo 2 computer. In this scenario, the increased number of processing cores has won the day. So the move to vastly more processing cores in modern processors is likely to drive applications to become even more multi-threaded than they are now. It really is a numbers game when it comes to processing cores. For this particular video, there are not 1 but 3 applications that have been created. The main application is the Generate Report executable. This is the one you've been seeing running on screen. We'll look at that application in a few moments, but first we'll look at what generates the data on which we're working. Inside the Data folder, there are 2 additional applications. There's a Generate Data application and an Extract File application. The Generate Data application is the one which will produce the raw data. There's a constant at the beginning of the application set to 100,000 records. You can set this to any number you like, and it will generate that number of random values in the file. The file is assembled from a number of smaller pieces. We have surnames and first names, eye colour, city, word groups, domains, and streets. This raw data is randomly sampled and records assembled from those records. For example, we pick a first name, we pick a surname, and we assemble the address and the other details. This will generate our 100,000 files, and is put into a file called My Large File. This file contains all the information we need. And on the right-hand side of the file is the user's email address. These are created randomly, as are all the other columns of data. Our second application is the extract file. This takes the information that's in My Large File and creates a second file with just email addresses in it. The scenario we're looking at here are every user in this file is going to be changing their email address. So the extract file will have the old and the new email address in the file. And the task of the Generate Report application is to load up the files and then update the main file to replace the email address with the new email address that's in the extract file. As there are 100,000 records in the main file, it will have to do this task 100,000 times. To do this by sequentially reading through the file one record at a time does take a long time. However, if we take the 100,000 records and split them up into a number of threaded processes and let each threaded process handle a portion of the file, this will give us an output for each thread that's processed, as we saw when we were running the application. Its first task is to work out how many processes are actually active on this computer. And if the value is 16, it will launch 8 threaded processes, exactly half the total number of threads that can be run by the computer. As you will see from the output that's being generated as we speak, it's going to create a number of email outputs. Each of these files will contain the values from the first section of the file, and it will have in it the person's new email address having been replaced. And as we can see, running this first one took 62 seconds to run the whole process in 8 threads. When we ran this on the new computer, it ran significantly faster, because on that computer there are twice as many threads available for processing. So let's have a look at the code itself. There are 2 crucial global variables: total sections, which is driven by the number of processing cores, and the maximum block size. That's the maximum size a block of data to be passed to one of the threads is going to be. We have a constant which we've declared as runThreaded equals true. If this constant is defined, then the application will run in threaded mode. If the application is not defined, then it will run unthreaded. So the first section is to work out how many processors we actually have, and this is done by a function called processor count. If we hit the F2 and have a look at that function, we'll see this is a very, very simple function. We used to have to use Windows API calls to work out the number of processors in the computer. This is now performed much more easily by using the environ command. This will actually interrogate the computer to look at the environment strings, and we're interested in the number of processors. This will return a string with the number of processors. So if we have a 16-core processor, it will return 16 as a string. So having worked out the number of processors, we can then call another function to work out the block size. This takes the name of our current data file and the total number of sections, which is the number of processors. So if we look at getBlockSize, it again is not a big function. Its first task is to open the file. This is our file with 100,000 records. It does a file scan, basically to count the number of records in the file, and then we're doing an integer division of the number of records by the total number of processors. This gives us the section maximum block size. Now that we have that key information, we can then go ahead to set up our threads. So if the constant runThreaded has been defined, we can then dimension 2 arrays, one for the threads and one for the thread status. And now we can start creating the threads. The threads are run from process file section, giving it this section number. So if we are running on a 16-core processor, we would run 8 threads. So that's from the value 1 to the value of 8. And the process file section is one we used in a previous video. And within this main loop, we are sending out to the console every 500 records processed. Obviously, the more you write to the console, the slower your application will be. And its job is to get the current email in the main file and then calls a function called findNewEmail to get the email in the array. And we're sending out to the output file the current data plus the new email. So all in all, it's a very small function, but running it threaded speeds up your processing considerably. So this application was ideal for testing the new computer, as I wanted to test out its multi-threading processing, as it has the ability of running up to 32 threads, one on each processor. You can of course run more threads than you have processors, but the more you add, the slower the system will become. Running a number of threads which is equal to half the number of processors you have, I've found to be optimal. It allows your application to move at a reasonable speed, but doesn't slow down Windows. So if you have an application which needs to process a great deal of bulk data, and it can be run in a multi-threaded mode, this is probably a good way to do it. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.